Consider the region bounded by y equals the square root of x plus 2 squared, x equals 2, and the x-axis. Right, so again, it's going to look like this right here. Oops. And so last time what we did was we revolved this around the x-axis and we got this kind of looking shape, right? It's a very rough picture of it, but that's essentially what we got last time. And then what we're gonna do now is find the volume of the solid formed by revolving this about the line y equals -1. And so y equals -1 is going to be this line right here. So here, let me show you what it's going to look like in 2D first when you revolve it around that line. So essentially, you're reflecting it about that line. And so the same amount of like space that you have here and here should be the same amount if you like translate that down, right? And so I don't know if that made sense. But yeah, so here, 1 unit below that line y equals -1, I'm going to have the horizontal line. And then I'm going to have the square root function, and then it's going to look like that. And so this is essentially what it looks like in 2D. So if I try and draw this in 3D, what it's going to look like is, so there's going to be my axis of symmetry, right? And then I'm going to have an open circle with no area, which represents this piece right here. And then a bigger circle that does have, I think I said area earlier, I meant volume, or like a solid piece to it, right? And so here, this should be filled in. And then it looks almost the same as last time. It's just essentially with a hole going down the middle of it, right? And so if you think back to the video that I had showed you on Wednesday, that is not, then that one actually had a washer in it, right? So this is what's called a washer. Well, actually not this. When you take a cross section, you're gonna get a washer. And so yeah, all of this should be filled in. So yeah, let's draw what the cross section is gonna look like. Which way am I gonna take my cross sections? Horizontally or vertically? Yeah, it's gonna be vertically, right? Because our axis of revolution, that's what it's called, is horizontal, right? So I'm gonna take my cross sections perpendicular to that. So when I take a cross section out of here, it's gonna have to have that hole in the middle of it as well, right? And so when I look at the 2D version of it, And remember, we're looking at the 2D version. So here, if I bring this out, actually I can make like a real circle. So yeah, it's gonna look something like this. And remember, yeah, the reason that we're taking these 2D slices is because we're gonna take their area and then add up all the areas that form the solid, essentially. We do that using integration. And so here, the way we're gonna kind of think about this, so when we just had one circle, right, we had that, let me use black. The volume was equal to the integral of basically pi r squared, right? Because we just had one piece, or like one circle with one radius, but now how many circles do we have over here in this circle right here? Or I guess in this, yeah, there's 2 circles, right? And so since I just want to find the area of this piece that I'm kind of coloring in blue, I need to subtract the area of this inner circle to get just this one, right? So you're gonna have a bigger circle. You're gonna consider like the outside one. So let's see how I wanna do this. So this is gonna be essentially your diameter, your first diameter. And then if you look at the center circle, then you're gonna have a second diameter, right? And so here, what we're gonna have is we're gonna have pi r1 squared minus pi r2 squared, where r2 is like both of this, or r1 is both of the circles like together, and then r2 is just that middle circle. And then here you integrate that with respect to x. So are there any questions so far about kind of the setup that we're gonna get here, or what it looks like? Do you guys want me to go back to the video that I had showed you on Wednesday, or can you kind of picture it? Okay. So yeah, what we're gonna do here, oh, okay, so some other people, instead of using like R1 and R2, they'll use like capital R and lowercase r, just in case you Google it. But so yeah, here, this is the same one that we had worked with last week, right? So this is -2 up to +2. So here our volume is gonna be from -2 to +2. And then for my first circle, for the bigger circle, let's look at it over here on the graph. What is its radius going to be given by? And so think about where the circle is. So the circle is not just this piece, right? Which is what it was when we took cross sections, when it was just disk. That's what the radius was. Our bigger circle now includes this empty space. So what is the radius given by here? Think about what you're doing to the radius that we had last time. So last time the height was just given by this square root function, but now what am I doing to the height by tacking on this piece? Okay, so yeah, exactly, right? So when it was just a disk, this was just given by the square root of x plus 2, right? And that's just that piece, this square root of x plus 2. But now we have this plus 1. If we were revolving it around the line y equals -2, you would add 2 to your height. If you were revolving it around the line y equals -3, you'd add 3 to your height, and so on, right? And so here, so let me undo that. You're going to have square root x plus 2 plus 1, and so that's going to be your first radius. down here. And then you have to square that, and then minus pi. And so now the inner circle, the second radius, is just given by this empty space, right? Because if you look at the over here, this green part is just the empty circle, which in 2D is just the space between the x-axis and the line y equals -1. So what's the radius given there? So R2 equals what? Yeah, it's just 1 in this case, right? And so here you have pi times 1 squared, and then you integrate all of that with respect to x. And so these integrals aren't terrible. I don't even have the answer to this one actually. But yeah, so here, I think when I ask you for these questions, I might just have you set up the integral, but we'll see. So here I'm just gonna leave it like this for now, but are there any questions about the washer method so far, just looking at this example? Does it make sense why we're having to subtract this second piece over here? Okay, cool. Let's do another one. So here, let me grab this one, yeah. So let's look at, so consider the region formed by y equals 4 minus x squared, y equals 0, and y equals -1. So y equals 0 is just the x-axis. Oh, wait, hang on. So sorry. This y equals -1, that's not the region. That's the line we're going to revolve it around. So consider the region formed by those. And find the volume of the solid when you revolve it around y equals -1. So here, I'm going to draw it out real quick. So 4 minus x squared, you can just graph that using parabola transformations, right? It's just going to be a parabola flipped or reflected across the x-axis, shifted up 4 units, right? And then so it's going to look something like this. It's probably not accurate, but that's okay. And then the line y equals 0, which is the x-axis. So here, let me make this a little bit more noticeable. So this is the region that we're considering. And then we're going to do the same thing. We're going to flip it around the same line, y equals -1. And so get something that looks like very similar on the other side. So it's definitely not accurate, something like this. So there's what it's going to look like in 2D. So this is the line y equals -1. Okay, so what would our first radius be given by? And so I'll try and draw it on here. So let me see. I don't know, orange is bad. It's like pink or something. So let's say I'm trying to find this height right here. What is this going to be given by? The easiest way to do it is to think about, okay, so what's the height from the x-axis to essentially the top of my region, right? And then add on that empty space. Yeah, exactly. So it's going to be 4 minus x squared plus 1. And then you can just make this, so r1 is then equal to 5 minus x squared. And then r2 is going to be just this space. So what is r2 equal to again? Yeah, it's just 1. And so now we can find the volume. And again, I'm just going to set up the integral. I'm not going to evaluate any of them today. So you have that the volume is equal to, oh, you know what? What are the limits of integration? Where does this function, the 4 minus x squared, where does that intersect with the line y equals 0? And so since the line y equals 0 is just the x-axis, that's just the x-intercepts, right? So what are the x-intercepts of 4 minus x squared? Yeah, 2 and -2. So this is definitely not accurate, but that's okay. And then, so you're going to do pi r1 squared minus pi r2 squared, and then integrate that with respect to x.